Hi, in this video I'm going to talk about decentralized applications and third-party services. Our content is node providers and oracles. So let us start with node providers. A node is a computer that stores a copy of a distributed ledger and participates in the decentralized network by validating transactions and blocks. Deploying a node requires specific hardware, software, network connection, and can come with technical challenges. Node providers aim to solve this challenge. In this regard, a node provider is a service that grants access to a node on a network, eliminating the need to self-running a node. They are crucial for blockchain network continuity and security. Let us see some of the functions of node providers. They maintain a copy of the blockchain ledger. They validate transactions and blocks. They are propagating new transactions and blocks. They are operating nodes on different blockchain networks. They are hosting nodes. They are providing APIs for accessing the blockchain, and they are offering tools for managing and interacting with the network. In this regard, let us understand visually what is the difference between running your own node and using a node provider. When you run your own node, you are basically interacting with a node through your DApp. But when it comes to a node provider, you connect to internet and a node provider interacts with the other nodes for you. And of course, there are several advantages of using node providers. Let us see them one by one. The first one is convenience. A node provider can handle the setup and maintenance of a node, saving you time and technical challenges, allowing you to focus on other parts of your project. Reliability. Node providers usually maintain their nodes with little downtime and high availability, especially for applications that must be accessible around the clock. Scalability. As the demand for your application increases, a node provider can handle scaling of your node and typically provides the flexibility to swiftly scale up or down as necessary. Security. Node providers typically have security controls in place to safeguard their nodes and the data kept on them. Cost effectiveness. Using a node provider can be a cost-effective option compared to setting up and maintaining a self-running node. Access to other services. Node providers often provide additional services such as Explorer, Analytics, webhooks, and backup. Let us understand oracles. To understand what oracles are, first we need to remember smart contracts. Smart contracts are self-executing computer programs that run on a blockchain. They automatically carry out the terms of a contract when certain conditions are met. A smart contract runs on the blockchain, which means it's isolated from the outside world and can't access information from outside the blockchain directly. This is where oracles come in. Oracles are specialized software or services that act as a bridge between the blockchain and external data sources, such as websites, databases, or off-chain systems. They enable smart contracts to access information from outside the blockchain network, and they allow them to make decisions and execute transactions based on external data. In this regard, we have some real-world knowledge that cannot be accessed from a smart contract. And to be able to have this connection between the smart contract and real-world knowledge, we need to use oracles. And they will provide us a connection between the smart contract and real-world knowledge. Let us also see real-world use cases of oracles in a blockchain system. Supply chain management. Oracles collect information from Internet of Things devices to track products as they move through a supply chain, enabling smart contracts to carry out transactions automatically. Decentralized finance. Smart contracts can trade and manage funds on a decentralized exchange thanks to oracles' access to real-time market data. Gaming. Oracles can access game data in the gaming industry, enabling smart contracts to carry out in-game purchases and power decentralized gaming platforms. Prediction markets. They also provide information on how events will turn out, allowing smart contracts to carry out transactions in accordance with the results. Insurance. To automatically execute payouts and claims on insurance smart contracts, oracles access external data. Identity and record management. Oracles can access and validate personal information, allowing smart contracts to carry out identity verification and records management procedures automatically. So there might be various types of oracles which can be classified into some categories, so let us see them. Hardware oracles. Hardware oracles rely on physical sensors such as RFID readers or GPS trackers to gather information from the real world and send it to a smart contract. In-chain oracles. They are smart contracts that are designed to gather information from other smart contracts on the same blockchain. They can also be called chain link oracles. Centralized oracles. Centralized oracles are controlled by a single entity or organization, and they are generally considered less secure and decentralized oracles. Software oracles. Software oracles gather information from online sources such as websites or APIs and send it to a smart contract. This type of oracle is the most common. Off-chain oracles. Off-chain oracles gather information from outside sources and bring it onto the chain. They can be seen as a bridge between the off-chain and on-chain worlds. Off-chain oracles. They gather information from outside sources and bring it onto the chain. They can be seen as a bridge between the off-chain and on-chain worlds. And lastly, we have decentralized oracles. They are operated by a network of independent nodes. This provides a higher level of security and trust. There can also be some other uses of oracles, so let us see them. Providing random number for your smart contract. Since the parameters used by the randomness functions written on smart contracts can be manipulated by the miners, it's not possible to generate a complete random number. At this point, random number information can be sent to the contract from outside blockchain with oracles. They can allow smart contracts to make decisions and execute their terms based on real-world events and conditions. For example, while developing a smart contract with Solidity, you may want to function to run every 10 minutes, but these contracts cannot run functions by themselves. At this point, you can use oracles. So it can be hard to understand the oracles at this point. So let us have a summary. As we know from our previous lectures, smart contracts are self-executing agreements that are stored and replicated on a blockchain, right? You don't need to have a deep understanding of how they are created or connected to the blockchain using our wallet, as I'll be providing a thorough explanation of the process. For now, what we need to know, smart contracts are designed to automatically enforce the terms of an agreement without the need for intermediaries. However, they do not have the ability to access data or information from the outside world. That's our problem here. This is because smart contracts run on a blockchain network and they can only access data that is stored on the blockchain. And the data that is stored on the blockchain is typically limited to transactions and data that has been entered into the contract. But there might occur another question here. Why do we need external data? We need outside information in a smart contract because many real-world situations require access to external data that is not stored on the blockchain, as I mentioned. For example, a smart contract that is used for a financial application may need to access real-time stock prices in order to calculate the value of the contract. Another example can be supply chain management, as I mentioned again, that needs to access external data such as temperature, humidity, location, and other environmental factors to validate the quality of the goods that are being tracked on the blockchain. So oracles in this regard act as a bridge between smart contracts and external data sources, retrieving and verifying external data such as temperature, humidity, and location. Then they send that information to the smart contract. This allows the smart contract to use external data and execute its terms, and this enables interactions with the outside world. This relationship between smart contracts, the outside world, and oracles enables the creation of decentralized applications that can access off-chain data and interact with the real world in a trustless and secure way. Alright, so that's gonna do it for this video. I will see you in the next one.